Welcome back. Today we are going to be looking at section 12.1, which is an introduction to conic sections. So today we're going to be looking just kind of at the basics, what they look like, and some key things we need to know in order to study them in depth. So first of all, what is a conic section? So a conic section is a curve that's formed when we have an intersection of a plane and a double cone. So we'll look at a picture of a double cone in a second. And the way we get that is we change the inclination of the plane, so how it's tilted basically, and we can come up with 4 different conic sections that way. The first one is a circle. The second one is an ellipse. The third one is a hyperbola. And then the last one is a parabola. So we're going to look at what those 4 conic sections look like. But again, we're looking at a curve that is formed by the intersection of a plane and a double cone. And depending on how we change that plane, we can make those 4 different conic sections. So let's take a look down here at what that double cone might look like. So a double cone, as you can see, has 2 cones kind of stacked on top of each other. That middle point that we can see is called a vertex. That's where the 2 cones intersect. And those cones are generated from this red line that you can see. So the red line shows that if we rotate or revolve that around that axis, this vertical axis that we can see in blue, when we rotate around that axis, that generating line creates our 2 cones that are formed. So that's what we're looking at. And then again, we're going to intersect that with different planes, and depending on how we move that plane, creates our 4 different conic sections. So let's look at our first one here. So the first conic section that can be formed is a circle. So this happens when a plane intersects one of the right cones, so either the top or the bottom, and it intersects perpendicular to that axis. So remember, we have a vertical axis from up above. So we can see from up there that if we intersect perpendicular to that axis with our plane, we create a circle. And you can see the graph of what that circle might look like, depending on where it's placed on the right. So that's our circle. The next conic section that we're going to look at is an ellipse. So an ellipse is formed when, again, a plane intersects with one of the right circular cones. So you can see that in the picture. We're still just intersecting one of them at a time. But this time, it's not going to be parallel to the generating line. So remember that generating line is the line that we're rotating or revolving around the axis. And we want to make sure that we're intersecting it not parallel to that generating line. When we do that, we create an ellipse, and you can see the graph of the ellipse. Okay, so it is almost oval shaped. That's kind of one way to think about it. So that's an ellipse. Next, we can create a parabola. So a parabola is formed again when we're intersecting one of the right circular cones, and this time we are going to make it parallel to the generating line. So again, that generating line is that line that we're revolving around the axis. And in this case, when our plane is parallel to that line, we create what's called a parabola. We've seen parabolas before in other situations, so the graph of that should look familiar. And then finally, we have a hyperbola. And this is the one where we intersect both right circular cones, or 2 right circular cones. So you can see that picture where it cuts through both of them. And when you do that, you get basically 2 cross sections that are graphed in that graph, and that's called a hyperbola. So hyperbola is the one that kind of has 2 parts to it. So we're going to study each of these more in depth in the next few sections, but for today we're just kind of getting a feel for what they look like. All right, the last piece that we're going to look at today is some key tools that we're going to need in order to be able to that we need to do when we start graphing the conic sections and just kind of figuring out what's going on with them, writing their equations, all that good stuff. So one key thing we need to remember from analytic geometry is the distance formula. So the distance is the distance between 2 points on a coordinate plane. So we have x1 and y1 as our first coordinate point, and x2, y2 as our second coordinate point. So the distance formula that we need to remember goes like this. D for distance equals the square root. If you remember from geometry, this is really the Pythagorean theorem just on the coordinate plane. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, it's a variation on the Pythagorean theorem, a squared plus b squared equals c squared, just applying it to the coordinate plane now to find the distance between 2 points. All right, and then the other formula that we need to remember from analytic geometry is the midpoint formula. So the midpoint formula, if we have the coordinates of 2 points on the coordinate plane and we want to find the midpoint of it, then we're going to find the segment with those endpoints on them, and then we're going to find the middle of it. So to find the midpoint formula, or the midpoint of 2 points on a segment, we're basically going to average the 2 points. So the coordinates would look like x1 plus x2 divided by 2. So finding the middle of the x coordinates, and then y1 plus y2 divided by 2, finding the middle of the y coordinates. So those 2 formulas are something we're going to use throughout the next few sections in order to find key points of conic sections. So we're going to practice with those a little bit here. So in example 1, we want to find the length of segment AB. So you can see in the picture that point A is at 1, 6 and point B is at 7, 2. So anytime we want to find a length, that's a distance. So I'm going to plug it into the distance formula. So if you remember from up above, the distance formula is x2. So I'm going to call x2 my second x value over here. So I'm going to call that 7 minus my first x value, which was 1. So I'm calling point 2 the B point and point 1 the A point. And then we square that and we add to it the difference between the y's. So my second y coordinate is 2 minus my first y coordinate, which is 6, and I'm going to square that again. All right, so when I simplify that, I'd have the square root of 6 squared, which is 36, plus negative 4 squared, which is 16. And that would give me the square root of 52 when I add them together. So when I simplify the square root of 52, I can simplify that to the square root of 4 times the square root of 13. And we know the square root of 4 is 2. So it would be 2 square roots of 13 would be the distance or the length of segment AB. All right, next it says to find the coordinates of M, which is the midpoint of AB. So using that same segment from example 1, we're going to find the midpoint. So in our midpoint, we average the x coordinates. So I'm going to do 7 plus 1 divided by 2. And we average the y coordinates. So I'm going to do 2 plus 6. And when I do that, my coordinate pair, 7 plus 1 is 8. 8 divided by 2 is 4 for the x coordinate. And then for the y coordinate, 6 plus 2 is 8. 8 divided by 2 is 4. So the midpoint of those 2 would be 4, 4, which we can see in the picture up there. All right, and then finally, we're going to use the midpoint to find our other endpoint now. So we're kind of working in a slightly different order on this one. So for this one, I know that one of my endpoints is at 4, 5. So I'm going to use that x and y coordinate up there to help me with my formula. So if I know the midpoint is 1, the x coordinate of the midpoint is 1, that's what it's going to equal. So I'm going to say the x of my endpoint plus 4, which is the other endpoint, divided by 2 has to equal 1. So when I solve that, I'm going to get x plus 4 equals 2. And so therefore x must equal -2. So I know the x-coordinate of my next point, or my endpoint C, is going to be -2. And then I'm going to do the same thing for the y's. So I'm going to say the y of my new endpoint plus the y of the endpoint that's given divided by 2 needs to equal the y of the midpoint, which is 2. So again, I'm going to solve that. Y plus 5 equals 4. So y, or the y coordinate of my other endpoint, is at -1. So if I go -1, -2, put a point there, that gives me a segment B to C that has a midpoint of 1, 2. All right, that's all for today. We're going to jump into our conic sections next.